Okay, let's unpack this. Imagine looking at a city, any city, and realizing that its very existence, its shape, its rhythm isn't accidental.
Not at all.
Every building that scrapes the sky, every tree-lined street, every public park where people gather, they are all, in a very real sense, shaped by this uh, invisible web of rules.
Absolutely. An unseen blueprint, we could say.
Exactly. These rules dictate everything from how tall a building can be to what materials it's made from to even what kind of activity can happen inside it. And this all happens long before a single brick is laid or, a drawing is finalized.
Long before.
That's what we're diving into today.
Yeah.
The intricate, often unseen world of zoning codes and building regulations. It's this kind of legal DNA that underpins all urban construction, profoundly shaping the places we live, work, and play.
It's true. And what's truly fascinating here, I think, is that these aren't just dry, dusty legal texts, not by a long shot.
Right.
Instead, they're living documents, kind of dynamic reflections of societal values, our technological capabilities, economic pressures, all of it.
So they change over time.
Constantly. Our mission today is to demystify this powerful, often arcane world for you. We're going to trace how these abstract architectural orders have evolved, starting from their early 20th century origins right up to today.
Okay.
We'll break down their key components, things like land use, setbacks, height limits, that kind of thing, and then explore their tangible, sometimes contentious impact on our cities.
And contentious is the word sometimes.
Definitely. This includes confronting some of the more controversial aspects of their history, particularly their documented role in perpetuating social and racial segregation. We have to look at that.
Yeah, it's unavoidable.
And also the public process, how these rules get debated and changed, the role of things like variances and special permits. Ultimately, we want to help you understand how these codified expectations translate into the bustling, diverse, or sometimes, segregated realities we experience every single day.
So what kind of sources are we drawing on for this? It sounds like a huge topic.
It is huge. And to understand this complex landscape, we'll draw from a rich tapestry of perspectives. We've got architectural historians looking at the very DNA of cities, urban theorists who challenge conventional wisdom.
Like Jane Jacobs.
Exactly. Plus, engineering and construction guides that reveal the nuts and bolts, the real practicalities, and even biographies of powerful figures who literally reshaped entire metropolises.
So a real mix.
Yeah, it's a blend of theory and practice, history and mechanics, all designed to give you a comprehensive understanding of the forces at play.
So let's start at the very beginning, maybe set the stage. When we look at a city, we often take its form, its layout, its character, just for granted. But as we just hinted, it's never accidental.
Never.
There's this fundamental tension at the heart of urban development, isn't there? This idea of whether a city grows organically, maybe sprawling naturally over time, or if it's born from a very deliberate, abstract plan, a kind of master blueprint.
Precisely. As the architectural historian Spiro Kostof puts it so well, the crux of the matter is whether an abstract architectural order is given priority and allowed to control the organization of the general layout, or whether site and function will shape the building. That's the core tension.
Okay, so abstract order versus site and function.
Exactly. And zoning and building codes are essentially the modern manifestation of this abstract architectural order. They are the deliberate top-down decisions that predetermine how land can be used and what structures can be built upon it, long before any shovel hits the dirt.
That distinction makes a lot of sense, and you can really see this contrast playing out throughout history, can't you?
Oh, absolutely.
I mean, think about some ancient cities. Like Kostof mentions this incredibly strict, almost geometric rectangularity of city blocks in El Cajon, that ancient Egyptian workers' town.
Right, super planned, very grid-like.
That's a clear, powerful example of an abstract planned order being imposed. Probably for efficiency, maybe control.
Likely both.
Now, if you imagine that, and then compare it to, say, a medieval European village that might have just organically sprung up along a winding river.
Following the contours of the land.
Yeah, exactly. With buildings bending and adapting to the land, to old paths, or just the immediate needs of the community right then, that's development shaped purely by the site and functional needs, without a grand, overarching design dictating every single turn.
And this isn't just ancient history, as you say. Many older European towns still show that organic, incremental growth. Streets wind, buildings follow natural topography or historical pathways. It feels grown, not planned.
Right.
But modern urban planning, especially from the 20th century onward, often leans heavily into that abstract architectural order. These codes aim to provide a predictable framework, ensuring certain standards of safety, public health, order, you name it.
But sometimes that comes at a cost.
Well, they can also at times limit the natural adaptive growth that gives some older cities their unique, often charming character. So if you think about your own neighborhood, its layout, its streets, its buildings, do you see the deliberate hand of design? Or do you sense a more organic, incremental growth?
That's a good question to ask yourself.
You might start seeing those invisible lines of the zoning code everywhere now, shaping your daily commute or even just the view from your window.
It's a fascinating lens through which to view the built world. And a big part of that deliberate design, that pursuit of order, it seems rooted in this historical imperative for standardization, almost like a drive for perfection.
Yeah, perfection is a strong word, but there's definitely a drive for optimization.
It's not just about things looking neat and tidy. It's fundamentally about making things work better, making them safer, building them more efficiently. Le Corbusier, the famous architect, talked about this in Toward the New Architecture, right? This need for establishing standards in order to face the problem of perfection.
He did. It sounds grand, maybe a bit philosophical, but it really underscores this foundational idea. By setting benchmarks, by creating uniform expectations, we aim for improved quality, reliability, and functionality in our built environment.
And he believed that setting standards actually fuels progress.
Absolutely. He argued that once a standard is established, competition comes at once and violently into play. Thus, we get the study of minute points pushed to its limits. Progress. It's a fascinating idea that standardization actually drives innovation within those constraints.
You can see that historically, can't you?
Dramatically. Think about something as iconic as the Greek temple. The Parthenon, for instance, didn't just appear fully formed overnight.
No, of course not.
It was the product of over a century of relentless standardization. Every component, every proportion, every aesthetic detail was refined and perfected through generations of builders and designers. It was iterative.
So building on what worked before.
Exactly. That allowed for what Le Corbusier called the apogee of this pure creation of the mind. This isn't just about looks. It's about optimizing function and form through a rigorous process where each generation builds on the proven successes of the last.
And it's not just aesthetic ideals or ancient temples, is it? We see that same principle, that relentless pursuit of progress through standard elements.
Yeah.
In the very building blocks of our modern structures.
Absolutely. It's completely fundamental to modern construction.
Think about standard lumber sizes, like 2x4s, which Edward Allen discusses in Fundamentals of Residential Construction, or those precast concrete elements mentioned in Francis Ching's Building Codes Illustrated.
Yeah, things we just take for granted now.
Right. But these aren't just arbitrary dimensions or shapes. They're meticulously standardized to enable efficiency, predictability, and, critically, safety in construction.
Predictability is huge.
When every 2x4 is roughly the same size and strength, builders can work faster, materials can be produced at scale, engineers can more accurately predict how a structure will perform. It's all part of that standardization drive.
It ensures that a building designed in one place can reliably be built in another, using components that meet known specifications. It underpins the whole industry.
Okay. So this leads us directly to the bedrock of this invisible web, the actual building codes themselves.
Exactly. We've talked about zoning maybe being the what and where.
Like house or factory, how big broadly.
Right. Building codes are the incredibly detailed rule book for how you physically construct those buildings. They are the essential legal framework ensuring public safety, health, and welfare, right down to the granular details of materials and methods.
That's a critical distinction, and they are incredibly comprehensive.
Oh, unbelievably so.
When you look at a resource like Ching's Building Codes Illustrated, it becomes clear these aren't just suggestions. These codes cover virtually everything.
Everything you can think of, and probably things you can't.
They outline, for example, the allowable building heights and areas, which are often determined by, the specific construction type?
Yes, construction type, the building's intended use its occupancy, like school, office, apartment, and whether it has modern fire suppression systems like sprinklers.
Right. Sprinklers make a big difference.
A huge difference. They also specify the structural integrity of every component, even down to the kind of structural materials to be used.
And how do they decide on those materials?
It's often based on rigorous standards developed by institutions. Think industry bodies, engineering groups, standards for proven strength, how materials are tested, quality assurance, all of that.
So it's very formalized.
Very. These aren't just guidelines. They are the legal backbone ensuring buildings don't fall down, as J.E. Gordon puts it so simply in his book Structures, and more broadly, that they function safely for their intended purpose, protecting everyone inside.
It's the ultimate safeguard built into the system, kind of operating quietly in the background until something goes wrong.
Exactly.
Yeah.
Hope you never need to think about why the code is written that way, but it's there for a reason.
Okay, now that we understand the sort of philosophical and historical background and the difference between zoning and building codes, let's get into the nitty-gritty, the actual DNA of these rules.
Let's do it.
One of the most immediately visible impacts of zoning and building codes is how they shape the very silhouette of our cities. I'm talking about fundamental controls like height and area limits.
These are absolutely fundamental, yes. They act as powerful, invisible sculptors of our urban environment. Ching and Winkle, in Building Codes Illustrated, lay out detailed criteria for how high and how large a building can be.
And it's not random, right? There are factors.
Not at all arbitrary. They are deeply influenced by crucial factors like the building's inherent construction type, wood frame, steel, concrete, its occupancy, what's it used for, and whether it has advanced sprinklers installed.
Okay, so those three are key. Construction type, occupancy, sprinklers.
Very key. For instance, a highly fire-resistant building may be constructed with reinforced concrete and steel and equipped with a state-of-the-art sprinkler system. Well, that might be allowed to soar to impressive heights and cover vast areas.
Makes sense. Lower risk.
Exactly. But contrast that with a less fire-resistant structure, say a typical two-story wood frame building without sprinklers. That would face much stricter limits on both its height and its overall footprint.
So the code balances risk and reward in a way.
That's a good way to think about it. The critical point is that a building's inherent safety features directly determine its allowable scale and density. It's a fundamental trade-off that shapes our cities in very visible ways.
It's incredible to think about how those, seemingly dry regulations lines in a code book directly dictate whether you'll see a soaring glass high-rise or a modest low-rise development in a particular area.
It's immediate.
These limitations and allowances profoundly influence not just a city's skyline, but its density, property values, how much sunlight hits the street, even the social fabric of a neighborhood.
Everything. It's why one block can have towering apartment complexes designed for hundreds of residents, while the very next block might be uniformly two-story homes, housing just a fraction of that population. It's all codified, a direct outcome of these regulatory decisions.
Beyond just the sheer scale of buildings, occupant safety is obviously paramount, especially when it comes to the risk of fire.
Always top of mind in building codes, they include incredibly detailed specifications for features like firewalls and exit requirements. And what's noteworthy here is the precision involved, often born from past tragedies, unfortunately, lessons learned the hard way.
Right. Building Codes Illustrated gives us very specific details about firewalls. These robust barriers designed to stop fire spreading, right?
Exactly. Compartmentalization.
For example, it dictates that no openings are permitted within a certain distance of a firewall, maybe 4 feet or so.
Typically, yes. Creates a buffer zone.
And any openings that are allowed, like doors or windows, are usually restricted in size. I think it said something like 156 square feet.
Around that, yeah. But here's where we see that pragmatic flexibility baked in. This size restriction can be increased if the buildings on both sides of the firewall are equipped with an automatic sprinkler system.
Ah, okay. So sprinklers give you a bit more leeway.
Right. It shows how various safety measures are interconnected. They can compensate for each other, offering different pathways to achieve the overall required level of safety.
And these rules, they exist for a critical, life-saving reason.
Absolutely. Ensuring occupant safety and preventing the uncontrolled spread of fire. Firewalls create that compartmentalization, limiting a fire to one section, buying precious time for evacuation for firefighters to arrive and contain it.
And exits are just as critical.
Just as critical. Codes include detailed exit discharge provisions. These dictate how occupants can safely leave a building and reach a public way, basically, a street or open area deemed safe, away from the structure itself.
Is there flexibility there? Every site is different.
There is. There's even flexibility on the part of the building official in determining when occupants are truly safe from the structure, recognizing that unique site conditions exist. Imagine a multi-story office building or a busy shopping mall.
Yeah.
These seemingly minor details about firewalls and exit paths are absolutely critical life safety measures. You hope they're never tested, but they are always present, silently protecting everyone inside every single day.
And it's not just the visible elements of those critical emergency measures. Building codes also delve deep into the unseen environment within a building. Things like air quality, ventilation, the very design of interior spaces.
Crucial for health and comfort. This is fundamentally about maintaining a healthy, comfortable, and sustainable environment for occupants.
And for the building itself too, right? Durability.
Yes, exactly. Chapter 12 of Building Codes Illustrated is kind of a fascinating catch-all that addresses these interior environment factors. It's not just about human health, but also about building durability, preventing issues like moisture damage, mold, unhealthy indoor air.
So what does it regulate specifically?
Well, the codes meticulously regulate the ventilation of building and occupied spaces, specifying how much fresh air needs to flow through to maintain good air quality. They include provisions for temperature controls, ensuring comfort. They mandate natural or artificial lighting levels for function and well-being. Even things like air and sound isolation between spaces for privacy and noise reduction.
Wow, okay. That's detailed.
It gets more detailed. They specify the sizes of the spaces to be occupied, ensuring adequate room. They cover access to unoccupied spaces, like attics or crawl spaces, for maintenance, and address ongoing sanitation and maintenance issues for building interiors.
Even crawl spaces.
Even crawl spaces. For example, those low, unfinished areas beneath a house might require continuously operated mechanical ventilation. If a vapor retarder, that's a material to stop moisture seeping in, is used, this ensures proper moisture control, prevents mold and mildew. Super important.
That's a great point about moisture control. It's vital for both the building's life and people's health.
Hugely vital.
The Builder's Guide to Hot, Dry, and Mixed Dry Climates offers more practical examples. It emphasizes, for instance, that ductwork shouldn't be in exterior walls or vented attics.
Right, to prevent energy loss and leakage. It saves energy, but also helps maintain consistent indoor temperatures and humidity.
And it highlights keeping indoor humidity in a specific range, like 25 to 60%, using ventilation, cooling, or dehumidifiers.
Yeah, getting that balance right is crucial. These details show just how comprehensively codes address practical environmental control. It influences the air you breathe indoors, the building's longevity, ensuring a healthy, comfortable, energy-efficient space.
Beyond environmental controls, codes also meticulously dictate the very materials used in construction and the methods for putting them together.
The actual building blocks and the instruction manual, essentially. This ensures consistency, structural integrity, and long-term performance. And it goes down to some incredibly small details, but those details have massive consequences.
It really does.
Yeah.
Ching's Building Codes Illustrated highlights how codes cover fundamental structural materials and their precise application, specifying things like the type of wood structural panel sheathing for walls and roofs.
Like plywood or OSB.
Right, and the exact connections, nails, screws, bolts used to fasten them, even the framing spacing, how far apart the studs and joists are. And this can change based on location.
Absolutely. It's often based on environmental factors like anticipated wind speed and exposure category for that specific area. A house on the coast needs different bracing than one inland.
So it's not just general rules, it's tailored to local conditions.
It has to be. And these material choices and construction methods, they're rooted in extensive research and constantly updated industry standards. Ching points out that these materials chapters are based on standards developed by institutions that concentrate on developing industry standards for specific materials.
So like engineering societies, materials testing labs.
Exactly. These groups, made up of experts, industry folks, building officials, develop rigorous criteria for strength, material design calculations, testing, and quality assurance. It's a whole ecosystem of standard setting.
So when you see a detail in a plan, like a concrete masonry-bearing wall with specific instructions for pressure-treated top plates anchored with 12-inch anchor bolts, or maybe fiber cement siding.
Those aren't just arbitrary choices by the builder or architect. They're decisions backed by scientific understanding, decades of engineering best practices, and a deep commitment to safety and durability.
And this ultimately dictates how long a building lasts.
Fundamentally, Stuart Brand, in How Buildings Learn, offers a striking comparison. He notes that the average life of a conventionally built stud house is about 75 years, whereas a timber frame is at least 300 years.
Wow, big difference.
Huge. These material specifications, rigorously guided by codes, fundamentally determine a building's lifespan and its resilience. It influences how long a part of our city will stand, how adaptable it might be over time.
Okay, so we've explored the abstract principles, the history of standardization, the really granular details within building codes. Now let's connect these invisible rules to the concrete realities we experience every single day.
This is where it gets really tangible for people.
The abstract rules we've discussed, they directly translate into the physical form of our cities, dictating everything from the shape of a skyscraper to where you can find your local coffee shop. They sculpt our urban landscapes in profound ways.
What's truly compelling here is how directly these regulations sculpt the urban landscape. They create the very character of our neighborhoods. Those height limits we talked about, detailed in documents like Building Codes Illustrated,
Yeah.
those are the direct constraints on how tall a skyscraper can be in a given area. You might have a downtown core where powers are permitted to soar, creating that iconic skyline. But just a few blocks away, strict height limits might ensure a uniform, human-scale streetscape.
And setbacks, too, the space between buildings.
Exactly. While our specific sources maybe don't detail every setback requirement, the general idea of the organization of the general layout that Kostoff talks about, that abstract architectural order, absolutely implies rules like setbacks. They dictate how far a building must be from property lines or the street.
Creating front yards, space between buildings.
Right, the open spaces we take for granted. And then, of course, there are land use regulations. These are subtly implied by the occupancy classification discussed in Xing's work. They fundamentally dictate whether a street is residential, commercial, or industrial.
So, use zoning.
Precisely. These aren't just invisible lines on a map. They are the powerful, tangible forces that determine the character, function, and even the feeling of every street and block in our cities.
It's like an urban choreographer, isn't it? Once you start noticing it, you see these invisible rules everywhere.
You really do.
It's why you might walk down a bustling street with vibrant mixed-use buildings, shops, restaurants on the ground floor, apartments or offices above, creating a lively, walkable district.
Yeah, lots of activity at different times of day.
And then just turn a corner and suddenly find yourself on a purely residential street, lined with quiet single-family homes, maybe big front yards, less traffic.
Total change in character.
This distinct differentiation, this deliberate separation of uses and forms, is often a direct, planned result of zoning decisions made years, even decades ago.
Yeah.
It truly is eye-opening once you start to recognize the unseen hand guiding it all.
However, and this is a big however, while these planning efforts, this abstract architectural order, are often intended for the public good, safety, order, protecting property values, they can also have profound and sometimes deeply unintended social impacts.
Right. This raises a critical question. What are the real-world consequences of these abstract regulations on the fabric of our communities, on the lives of the people who live within them?
And here's where it gets really interesting and frankly quite challenging, as you said earlier. Jane Jacobs, in her seminal work, The Death and Life of Great American Cities, was a fierce critic of large-scale, top-down urban planning precisely because of these unintended consequences.
She really shook things up.
She absolutely did. She observed that lack of enough mixed uses is precisely one of the causes of deadness, danger, and plain inconvenience in a city. She believed that when planners imposed homogeneous, single-use districts, say, an area zoned only for residential housing or only for offices, even with the best intentions.
They often killed the vitality.
Exactly. They often inadvertently destroyed the very vitality, the diversity, the spontaneous social interactions, the eyes on the street that make urban life rich and safe. Without a mix of people doing different things at different times of day, she argued, streets become empty, unsafe, and just plain uninteresting. Dead zones.
And she took it further, didn't she? Linking planning to economic problems.
She did. Jacobs argued that hopeless economic contretemps seldom turns up naturally in a city, but it is frequently introduced by plan. This is a really crucial insight, a powerful indictment of planning that ignores the organic complexities of city life.
So planning itself could create problems.
It highlights how planning, rather than always solving problems, can inadvertently create them, leading to areas lacking economic diversity, social interaction, real community resilience. And if we connect this to the broader picture, these issues of homogeneity, lack of organic diversity, well, they're often underlying factors that historically and currently, can contribute to segregated realities within cities.
This is the really sensitive part we mentioned.
It is, and it's important to be clear here. Historically, zoning was sometimes explicitly used to separate different social and economic classes, and yes, in many unfortunate instances, different racial groups. But even when not explicit, when areas are planned to be, say, solely large lot, single-family residential, isolating them from commerce, transit, or varied housing types.
You can make them inaccessible.
It can make them less accessible and less economically viable for diverse populations. This can perpetuate social and economic divides that manifest as segregation. We're reporting here on the documented effects and critiques of these planning approaches, as found in urban studies and history, without endorsing any specific political viewpoint. But the connection is there in the analysis.
That's a really critical distinction, understanding the documented effects. Jacobs observed, for instance, that grand residential projects downtown, which were often intended to bring new life back to city centers.
Yeah, the urban renewal push.
They only truly succeeded, she argued, when they were part of a very complex pool of downtown day, night, and weekend uses in reasonable balance. Without that genuine organic mix, people sorter, living, working, shopping, socializing, all at different times.
They just didn't integrate.
Right. These projects could become isolated islands, dead after 5 p.m., not truly part of the city's life. It really highlights the profound challenge of trying to impose urban diversity and vitality through grand, top-down planning, when what's often needed is maybe a more nuanced bottom-up approach that fosters organic growth and interaction.
And this leads us to the monumental figures, the power brokers, who, with grand visions and immense political will, literally shape the concrete realities of our cities, sometimes for generations.
Leaving a massive footprint.
A massive footprint, and perhaps no one exemplifies this kind of top-down transformative power more profoundly than Robert Moses, whose actions profoundly reshaped New York. His legacy is still debated fiercely today.
Robert Moses, yeah, Robert Caro's biography, The Power Broker, is epic.
Yeah.
He was truly a colossal figure, a force of nature in urban planning.
Absolutely. He wasn't just planning, he was building empires, almost single-handedly redefining the infrastructure of New York City and its surroundings.
Caro describes these grand visions. 40,000 acres of parks, an astonishing 124 miles of parkways, which Moses conceived as ribbon parks, blending roads with green space.
He aimed to connect vast areas, creating huge systems like the Belt System, that great circular bypass around the city. It was about traffic flow, yes, but also recreation, reshaping how people moved and experienced the region.
It really illustrates how a single individual, wielding immense power, often by consolidating authority across numerous agencies, finding legal loopholes,
Master of the bureaucracy.
could implement these vast top-down systemic engineering visions, as Carlo Rotti might call it. His vision was total, and his methods were often, well, ruthless.
And this wasn't a smooth, universally acclaimed process at all. These grand visions often generated what Caro describes as an often contentious public process. Moses frequently bypassed or outright ignored local input, prioritizing his grand regional plans over communitative concerns.
There were clashes, right?
Major clashes. Caro vividly details them. He recounts how Governor Lehman, advised by people who knew Moses well, ignored Moses' charges and used his own political policies to counter Moses' seemingly unstoppable momentum.
And that famous incident with the controller.
Oh yeah, Comptroller Joseph, during a Board of Estimate session, refused to approve design contracts for a Moses project, led to Moses' public indignant threat. If I don't have the sufficient confidence of this administration, I don't want to be parks commissioner, and I don't want to be construction coordinator, basically threatening to quit multiple jobs at once.
Wow, that's political theater.
It shows how influential figures can, through sheer political will, strategic leverage, mastery of the system, enable or block work required for desired outcomes, just like project management principles describe. His story is a stark, complex reminder of the immense power that can be concentrated in urban development and the long-lasting social and physical changes that result, sometimes overriding local input, sometimes creating new, unforeseen challenges. His legacy is transformative infrastructure, yes, but also communities divided, diverse neighborhoods disrupted. It's deeply complex.
So we've seen how these elaborate systems of rules get set, abstract orders, detailed codes, and how powerful figures can sometimes bend them to their will. But what does this all mean for the future? Once buildings are designed and built according to these rules, how do we adapt them? Adapt them to the changing needs of a dynamic city or unexpected realities on the ground.
That's a fundamental challenge.
It seems like there's this inherent rigidity in design and regulation versus the constant, undeniable need for adaptivity.
This is a core and often really frustrating tension in architecture and construction. Stuart Brand, in his fantastic book, How Buildings Learn, points out that adaptivity during construction is often punished by claims.
Meaning, changing the plan gets you sued.
Basically, yeah. Any deviation from the original approved plan can lead to costly legal disputes, delays, financial penalties. It discourages mid-course corrections.
And architects sometimes contribute to this rigidity.
Brand argues that architects, especially those influenced by the modern movement in the mid-20th century, often sought total control and promised total prescience. They aimed for designs that were so perfect and complete on paper that they'd never need to change.
A sort of perfect static object.
Exactly. This mindset, combined with prescriptive codes, led to buildings that, once built, actually defied easy change or adaptation. They became inherently less flexible to future needs or evolving lifestyles.
So that rigidity, embedded in codes and maybe even design philosophy, is a significant challenge.
It really is, especially when buildings need to serve multiple generations and unforeseen uses over decades, even centuries. It's why sometimes a beautifully conceived design can become functionally obsolete much faster than anticipated. It just can't flex to new demands.
It's a fascinating paradox, isn't it? A system designed for order and perfection can sometimes hinder evolution and necessary change. Think about your own home or workplace.
Yeah?
How has it adapted over time? New tech, growing family, different work styles. Maybe you added a home office, renovated a kitchen, put in smart home stuff.
Constant little changes.
Would those adaptations, big or small, even be allowed under current codes if the building were constructed today? Or would they require some kind of special permission? It really highlights how a system designed for one moment can struggle with the fluid nature of human life.
Given this inherent rigidity, there absolutely has to be a mechanism for navigating these rules when reality inevitably deviates from the plan. Because it always does.
Right.
And while variances and special permits aren't explicitly detailed chapter and verse in our core sources as dedicated sections of a zoning code, the underlying concept needing to adapt to unforeseen conditions is hugely present in project management, which is, after all, the art of bringing complex plans to life in the messy, real world.
Absolutely. This is where theory meets practice, right? A PMBOK guide, the Project Management Bible, talks a lot about risk management activities and the project manager's ability to adjust to the changing needs of the end user, sponsor, or customer.
Things change. Needs evolve.
Think about it. A developer might hit unexpected rock formations on a building site, needing a foundation change. Or maybe a community's needs for a library evolve mid-project, requiring a design tweak. Without a mechanism for flexibility, a variance in zoning terms or a change order in construction progress would just grind to a halt.
Leading to abandoned projects, wasted resources. You need those escape valves.
Exactly. And construction management texts, like from the CMAA, frequently mention permits as key. But permits aren't just simple yes or no stamps, are they? They often involve an approval process that allows for adjustments.
Right. A zoning variance, for instance, is a formal authorization to deviate from a specific zoning rule. It's typically granted when applying the strict letter of the law would cause an undue hardship that's unique to that specific property, not something common to the whole neighborhood.
So it's case by case.
Very much so. A special permit, on the other hand, allows a use that isn't typically permitted in that zone, but which, under certain specific conditions, is deemed appropriate and beneficial to the community.
Like maybe a small daycare in a residential zone.
Exactly. Something that serves the neighborhood but isn't the primary allowed use. So these are the safety valves, the mechanisms that allow some flexibility within an otherwise rigid system.
The CMAA standards even address situations like when the contractor is seeking a time extension for a project. Their preference that time extensions be negotiated and agreed to before the associated delay actually occurs.
Proactive adjustment.
It's not just about scheduling. It reflects a broader, pragmatic understanding that sometimes the original idealized plan must be bent or altered in the face of reality, unforeseen site conditions, material shortages, evolving stakeholder needs.
These are the practical analogs to zoning variances or special permits. They're the essential safety valves that allow projects to proceed even when they deviate slightly from the initial blueprint. They prevent entire developments from being blocked and allow our cities to actually evolve, albeit sometimes slowly.
So it highlights this constant tension. How do we balance the need for predictable rules and standards with the equally crucial need for flexibility and adaptation.
It's a delicate dance, a constant negotiation between maintaining order and allowing for organic growth and innovation.
So how do we manage all this complexity? How do we explore possibilities, ensure compliance within these elaborate rule sets, especially with this dynamic tension between plans and reality, the need for adaptivity?
Well, thankfully, technology is offering powerful and increasingly sophisticated solutions that are really transforming the entire process.
You mean things like computer modeling?
Specifically, building information modeling, or BIM. As Chuck Eastman details in the BIM handbook, BIM is far more than just fancy 3D visualization. It's a comprehensive digital representation of a building's physical and functional characteristics.
A digital twin.
Essentially, yes. It facilitates the design of large and complex models in 3D, creating this rich, data-infused digital version of a building. But it's becoming indispensable not just for design, but crucially for code compliance through mechanisms like model view definitions, or MVDs.
Okay, MVDs, what are those?
Think of them as standardized subsets of the BIM data that can be used to automatically check specific things. Structural analysis exchange, transfer of as-built data to facility operations, site planning, code compliance, quantity takeoffs, and others. Basically, BIM allows for automated checking of a design against regulatory requirements before you build.
Catching potential issues early.
Exactly, long before construction even begins. It's like having an incredibly intelligent digital assistant, a virtual detective scrutinizing every aspect of a design against the rulebook.
Barbara J. Jackson, in Construction Management Jumpstart, elaborates on this. She explains that BIM allows designers to run a variety of studies, simulations, and what-if scenarios in a virtual environment.
Testing things out digitally.
Imagine being able to test a building's energy efficiency, its accessibility for people with disabilities, ADA compliance, or how different spatial layouts impact foot traffic, all before breaking ground. BIM keeps track of the different databases that comprise the project, tracking the various impacts those scenarios have on everything from energy efficiency to AD compliance to spatial relationships.
It enables proactive problem-solving, optimization, early identification of conflicts or code violations in a virtual space. That saves immense time and money in the physical world.
The benefits sound huge.
They really are profound. Eastman notes BIM leads to a reduction in drawing errors due to the built-in consistency of a central building model. Change something once, it updates everywhere.
Less room for human error.
Much less. This also results in improved engineering productivity and the elimination of design errors based on spatial interferences. Avoiding those costly clashes where a pipe tries to go through a beam.
Nightmare scenarios for builders.
Absolutely.
Yeah.
And crucially, it facilitates communication among the actors in a project. Owner, architects, consultants, contractors, fabricators, potentially operators, everyone's working off the same coordinated digital model.
So, fewer mistakes, better collaboration.
And ultimately, better performing buildings that are far more likely to meet or exceed regulatory standards, plus potentially more adaptable and efficient throughout their life cycle. It's really transforming how we approach design and construction within the confines of these complex yet essential rules. #outro.
Wow. Okay, so we've journeyed from that historical drive for order and perfection in our cities, tracing the origins of zoning from its early 20th century start as a tool to separate uses.
Which had its own complicated history.
Definitely. We've delved into the intricate details of modern building codes, understood mechanisms for change like variances, explored the powerful figures who shaped our cities, and even confronted the challenging, controversial aspects of zoning's role in social and racial segregation.
Yeah, we covered a lot of ground.
We've seen how these invisible rules become the very visible reality of our urban landscapes, impacting everything from the height of a skyscraper to the air we breathe indoors and the very character of our neighborhoods.
This deep dive really reveals that the zoning code, far from being just a static set of dusty regulations, is a living, evolving framework.
Constantly being negotiated.
Exactly. It's a constant negotiation between ideals of order, the practicalities of construction, economic pressures, societal values, and that enduring human need to shape our environment. Understanding these rules is an essential practice, really. Whether you're a developer planning a project, an architect designing a building, a builder constructing a home,
Or just someone living in a city.
or just a curious citizen wondering why your favorite coffee shop is located right there. It's the legal DNA that guides every hammer blow and every architectural flourish. It defines the possibilities and constraints of our shared urban life.
And as we move forward, the relationship between these rules and our cities continues to evolve, pushing the boundaries of what's possible.
Indeed. In a world of increasing interconnectedness, ubiquitous computing, Carlo Ratti, in The City of Tomorrow, suggests something interesting. He says, the city of the future will emerge from collaborative futurecraft at the intersection of the digital and physical worlds.
Collaborative futurecraft, I like that.
It challenges that historical dominance of purely top-down frameworks, suggesting the future of our urban spaces might increasingly depend on bottom-up actions and smart citizens engaging with and perhaps even hacking these complex systems
Hacking the city.
in a sense, which raises a truly provocative thought for you to consider. As our cities become more digitally layered, more responsive, will the power to shape them shift further into the hands of an informed and engaged citizenry? Or will it simply create new, more complex systems of control, maybe controlled by tech giants or governments in new ways?
That's a big question.
It leaves us to wonder what new forms of urban order, or perhaps beautiful, productive chaos, will emerge when potentially every citizen becomes a kind of urban architect, armed with knowledge and technology, able to interact with these systems in real time. What does that future look like?